Hope you are understood the basic definitions. Okay, now we will discuss the what is the limits and the tolerance. Okay, limits nothing but what? It's a two extreme permissible values between which the actual size of the component is present. Nothing but I will show in the figure what is that this one two extreme permissible values is. So hope you are all understood the basic definitions. In that basic definition we have mentioned the maximum limit and the minimum limit, right? So the difference between maximum limit means what? From here to here this maximum and here to here is minimum. The difference is what? That is a tolerance. And the basic size is what? From the bottom to the zero line is what? Basic size. But actual size is what? From this point to the this line. From this line to this line is what? Actual size. Here we have discussed the actual size, right? This actual size is nothing but what? Only this much, not with respect to the zero line from here to here. Okay, now I will draw again one more time the respect to what? Hole. So this is the hole. Basically this is the center of the hole. This is what the center of the hole. Now the distance between from here to here. Now I will hatch this one. What? So distance between this to this is what? Actual size. So from here to here is what? So minimum or it's a minimum or lower limit. You can call it as a from here to here is the minimum or a lower limit. So from here to here we are drawn separate part like this, right? From here to here is nothing but what? Maximum or upper limit. So this is what the upper limit and this is what the lower limit. The difference between these two we can call it as a what? Tolerance. So here the related to limit, the two extreme permissible values. What are the two values here? The minimum limit and the maximum limit, maximum size and the minimum, which the actual size of the component is present, in which the actual size of the component is present. So we are different maximum limit and the minimum limit. So related to the tolerance nothing but what? Here and the maximum limit is what? Of the size is greater the values of the two limits. So maximum permissible size of the workpiece we can call it as what? Maximum limit here. And the minimum limit of the size is what? Smaller the value of the two limits. What are the two limits? Here upper limit and the lower limit. Of the two limits, for both the two limits, the minimum the size of which the smaller value we can call it as a what? Minimum limit. That is minimum size. Now if it is related to the tolerance nothing but what? It is an algebraic difference between maximum limit and the minimum limit of a hole or a shaft. Here if you draw any shaft here, if you draw one shaft, this is center of this one shaft. I have to add this one. So here this is what? From here to first line is what? Minimum. From here to here we can call it as a what? Maximum limit. The difference between these two we can call it as a what? Tolerance. This is with respect to hole and this is with respect to the shaft, the hole. Okay, it is algebraic difference between the maximum limit and the minimum limit of the hole. And it is difference between the upper deviation and the lower deviation. So you're all familiar with upper deviation and the lower deviation. Here see, upper deviation nothing but what here? So maximum limit to the actual size is what? Upper deviation, and minimum limit to the zero up to zero, distance between the minimum limit to the zero line we can call it as what? Lower deviation and the upper deviation. Okay, so it is a difference between the upper deviation and the lower deviation, and it has absolute values without sign. So this is regarding the tolerance. So now with respect to the tolerance zone is nothing but what? For example, if it is a shaft of diameter of how much? 30 plus or minus 0.4 mm. So 30 plus or minus 4 nothing but what? Initially in the introduction I have given the example of what? The shaft and the bearing, right? So 30 plus or minus means what? 30 plus 0.4, and lower, this is what the upper limit, and the lower limit is what? 30 minus 0.4 is, this is what the lower limit. So this is the upper limit and this is what the lower limit values. Variation is what? 30 minus 0.4 and 30 plus 0.4. The tolerance zone is of how much? Tolerance zone is of how much? So this minus this, we can, the tolerance zone is of how much? This is equal to 0.8 mm. This is the tolerance zone. This is the tolerant zone value. So this is upper limit value, lower limit value. Okay, this is about. Now we will discuss the types of the tolerance. So types of the tolerance, we are having two types of the tolerance. One is unilateral and the bilateral. Related to the unilateral, when the tolerance is allowed only on the one side of the nominal size. So we are all familiar with the nominal size, right? Nominal size nothing but what? It is a size which is specified in the drawing. It is specified in the drawing. Initially, we are in the basic definition, we are find out what is the nominal size. It is a size by which it is specified in the drawing. So related to the unilateral, take any one zero line. For example, we have taken one zero line here. This is what zero line. In the basic definition, we are discussed regarding the zero line, that is upper deviation and the lower deviation. So in the zero line, here the system of it allow nothing but what? Tolerance is allow only in the one side. For example, if the example is what? 30 plus 0.02 minus 0.0. If the problem is like this, if the way of representation is like this, 30 plus 0.02 and minus 0.0, this represent what? Unilateral tolerance. Nothing but what? This is the basic size is what? Basic size is 30 mm. Basic size is 30 mm plus 0.02 means what? Here plus 0.02 and minus 0 means what? Here in this line. Only in the one side of the tolerance, only one side of the nominal size, only one side of the nominal size. This type of tolerance we can call it as a what? Unilateral tolerance. Understood? Okay. Next, then with respect to the bilateral tolerance, bilateral nothing but what? When the one limit of the size is on one side, and nothing but what? If they take an example 30 plus 0.02 and minus 0.02, if the representation is like this, then one limit, upper limit and the lower, upper limit, one limit is on one side of the zero line and other limit is in the other limit of the size is on the other side of the zero line. Take for example, if I take any one zero line here, zero line, this is what? Zero line, and the basic size is how much? Basic size is equal to what? 30 mm. So one side is of how much? 0.02, that is plus above the under one side of the zero line, and another side is of how much? Again 0.02, that is minus 0.02 here plus 0.02. This is what the representation of the bilateral tolerance. So one type is of how much? Unilateral, and second type is of how much? Bilateral. And what is the limits? Limits is nothing but what? Maximum limit and the minimum limit. Maximum nothing but from this line to the above line we can call it as a what? Maximum, and basic from bottom to the initial we can call it as a minimum limit and the maximum limit. And the difference between maximum and minimum is what? Tolerance. In that tolerance we are having two types. One is unilateral, only one side of the zero line, and the bilateral nothing but what? Another both side on the zero line. On this one side of the zero line, another side is on both the upper limit and the lower limit you will get. Okay, then come to the another important concept, that is fits. Fit nothing but what? When the two parts are to be assembled. For example, when the two parts are to be assembled, the relation resulting from the difference between their sizes before assembling. Before assembly, there should be some difference between their sizes. That is that assembly, that concept we can call it as a what? Fit. Okay, and another, it is a degree of tightness or looseness between the two mating parts to perform a particular function. To perform a particular function, whether the two mating parts has to be tightness, the degree of tightness, and to check the degree of tightness and the looseness between the two mating parts. That is that concept we can call as a what? Fit. Okay. Okay. In that fit, according to the actual limit of the hole or a shaft size, fit may be classified into three types. According to the actual limits of hole or shaft size, we can classify the fits into three types. So first one is what? Clearance fit, interference fit, and the transition fit. So now now I will explain by giving the figure what is meant by the clearance fit. First we can draw the one hole and the shaft, initial basic drawing. Just I will write the free sketch just to understand. Here you can shaded part. Okay, this is the center of this one, hole center. Now we have to draw the, this is what? Hole. This is the center of the shaft. Now for these two we are drawing a one basic line or a zero line, not basic line, basic size, that is zero line. This is common for both one. So the minimum clearance, the clearance fit nothing but it is a difference between the size of the hole and the shaft before assembly. So to before assembly, the difference between the size of the hole and the shaft, this is the shaft and this is the hole. So the minimum limit is what? Here to here is the what? The minimum limit, and here to here is what? Maximum limit. From here to here is what? Shaft minimum limit, and from here to here maximum limit. Okay, so now we are dealing with respect to the clearance. The word they represent what? Clearance. It is the difference between the size of the hole and the shaft before assembly. Okay, in this type of fit, the largest permissible shaft diameter is what? Smaller than the smallest size of the hole. Nothing but what? The maximum limit is what? The maximum limit line of the shaft and the minimum limit line. That is what? The minimum clearance. And the minimum limit of the shaft and the minimum limit of the shaft and the maximum limit of the hole, we can call it as a what? Maximum clearance. So try to understood. So here the minimum line of the hole and the maximum line of the shaft, the difference between these two we can call it as a minimum clearance, and the minimum line of the minimum limit of the shaft and the maximum limit of the hole, the difference of these two we can call as a what? Maximum clearance. So okay, the tolerance zone of the hole is completely above the tolerance zone of the shaft. That is, this type of fit we can call as a what? Nothing but a clearance fit. Nothing but what? It is a positive difference between the maximum limit of the hole and the minimum limit size. That is nothing but a maximum clearance, and the positive difference between the minimum limit of the minimum limit size of the hole and the maximum limit size of the shaft, we can call it as a what? Minimum clearance. So this is what the best example of the what? Clearance fit. Nothing but examples we can write it as a what? Sliding fit, helpful in quiz, and in the competitive exam they may ask sliding fit, running fit, and loose running fit. These are the best examples of what? Clearance fit. Nothing but what? Positive dimension of what? Maximum limit of the hole and minimum limit of the shaft, and minimum limit of the hole and the maximum limit of the shaft. That is not the minimum clearance and the maximum clearance. Hope you are understood. So now now we will go to the another type of fit we can call as what? Interference fit. Interference fit, again I will draw one more figure related to the hole and the shaft. This is what? The hole. This is the center of the hole. this is what the center of the shaft. So this is what the main basic line, all are common basic line for both the hole and the shaft. That is zero line, not basic line, sorry, this is zero line. Okay, here you are understood that what here is what minimum limit, and here is what the distance between these two, and what maximum limit, and from here to here is what minimum, from here to here you can call as what maximum limit, okay, of the shaft. This is what the shaft and this is what the hole. Now the difference between the minimum interference and the maximum interference. Interference nothing but what in this type the minimum permissible shaft diameter is greater than the maximum permissible hole diameter. So in what is the meaning of that one means what minimum permissible shaft diameter. Minimum permissible shaft diameter is nothing but what here the upper limit and the lower limit of this one. So upper limit, the maximum limit with the minimum limit, we can call it as a what minimum interference, and the maximum of the hole and minimum of the this one, and here minimum of the hole and maximum of we can call it as a what same like that of in the previous, nothing but a maximum interference. Okay, the negative difference between the maximum limit size of the shaft, maximum limit size means what here maximum limit size and the minimum size of the hole, minimum limit size of the hole, here to here we can call it as a what maximum interference, and the negative difference between the here one thing you can easily understood that here is what the positive difference, here you are dealing with respect to what negative difference, negative difference, here clearance fit is what positive difference, one thing. So definition is a positive difference between maximum with the minimum and minimum with the maximum. So two same like that of here, so minimum with the maximum limit of the shaft and maximum of the hole and minimum of the this one, this is what the minimum interference and the maximum interference with respect to what negative difference. This is related to the interference fit. Okay, now we'll move on to the another type, and the last type of the fit, nothing but transition fit. Transition fit is nothing but what we are drawing one basic size, right? We are all familiar with the minimum limit and the maximum limit, yes or no? So in the minimum and the maximum limit, in this case the size limit of the hole and the shaft are selected such that either clearance of the interference may occur depending upon the actual size of the parts. Clearance may occur with the actual size of the parts. In this type, see here again I will draw one more figure related to the hole. This is the hole and this is what the shaft. While writing, both lines should be in the same line. Okay, both the centers are in the same. You have to this one understood here, both the center of the hole and the shaft should be in the same line here in the transition. So previously we are what we make a center here and here on center and here on center and above this one. So this is negative difference, this is the positive difference, but in the transition fit both the centers are in the same direction. So now we will draw the one basic line, that is a zero line, sorry. So this is what the minimum limit and this is what the maximum. So here in the above line, this is what the minimum, this is what the maximum. Okay, this is shade, forgot a shade, very important representation. So both the centers are in the same. So the largest permissible hole is nothing but what minimum limit. Here this is what the basic size. greater than the small, but the smaller diameter of the hole is smaller than the larger diameter of the shaft. That is the main difference of the transition fit. Okay, one more one more time I will repeat. So in this type of fit, the largest permissible hole diameter, largest diameter is greater than that of the smaller diameter of the hole, but the smallest diameter of the hole is smaller than the larger diameter of the shaft. That is very important. So only our representation is like this. Okay, by seeing the figure itself only we come to know. Understood? Okay, thank you. Related then again we will discuss in the next video related to the hole basis and the shaft basis system. That is very important. Okay, thank you.